Today we're going to take a look at my latest project, which is where I attempt to build my own smart central heating control system. So what we'll do is we'll take a look at some of the hardware I'm using for it, take it apart a little bit, I'll then go and build it and sort of check in as I'm building it and show what I'm doing, then we'll install it and see how well it works. Now let's take a look at all the hardware we'll be using. So as you can see, we're basing this around the Sonoff TH16 smart Wi-Fi switch. For people that haven't seen Sonoff devices before, they're effectively really cheap Wi-Fi enabled switches that you can use for various projects. Out of the box, they're fairly standard devices. They connect to your Wi-Fi, then attempt to connect to the manufacturer's cloud service, and you can download their app and use their app with it. However, these things are actually extremely hackable. They're based around a chipset called the ESP8266, which effectively is a Wi-Fi chipset with built-in microcontroller that's fully Arduino compatible. This means that you can either write your own firmware for it, or you can download many pre-made firmwares and load them onto the device. In my case, I'll be writing my own Arduino firmware and flashing it onto this. The TH models are the temperature humidity models, which have a connection there, which the other ones do have, but these ones are designed to connect up to these temperature and humidity sensors. These are sold separately, which I made a mistake when I bought it because I bought this on its own. You do have to buy these separately. This little device that plugs in with that connection there, it uses the one wire protocol to talk to the Sonoff, and this contains both a temperature and a humidity sensor, which is great for this project. The 16 in the model number of the Sonoff means it has a 16 amp relay, so it can switch 16 amp loads. There's also a slightly cheaper one called the TH10, which has a 10 amp relay. Now in my situation, I'm only going to be switching in the order of milliamps because it's just a signal to my boiler, it's not an actual heavy load on it. The only reason I bought the TH16 is because I bought the wrong one. I wasn't reading the listing properly and bought the wrong thing. So I spent a couple of quid more than I needed, but it'll work absolutely fine for what we're doing here. The next piece of hardware we'll use is this USB to TTL cable. The Sonoff has a TTL header inside it for programming, so all you do is connect one of these cables into it with those wires, plug it into a PC over USB, and you can upload your firmware to it. The key thing with this is that you need to get one that's capable of 3.3 volts on both the voltage output and the TX and RX connections. That's because the Sonoff requires 3.3 volts and it'll quite likely get fried if you feed 5 volts into it, so make sure you get one that's 3.3 volt capable. That's either fixed to it, or in the case of this one here, which is quite nice, is switchable with this jumper here. The one thing to be very careful with is that some of these say they're 3.3 volt capable, but they're actually not. They'll output 3.3 volts on one of the voltage pins, but the TX and RX pins will still be at 5 volts and you'll fry the Sonoff. So make sure you get one that definitely has 3.3 volt signals, not just the voltage output. I'd also recommend checking it with a multimeter before plugging it in, as 5 volts has been shown to quite reliably fry Sonoffs. The final bit of hardware we have here is this, which is the JG SpeedFit sensor box. This thing was stupidly expensive from Screwfix, it was like 14 quid, but it's just a very nice little housing to put the sensor in. It's actually designed for JG SpeedFit underfloor heating systems, but all it is an empty box that I can take the PCB out of this, mount it inside the box, and this will look a lot nicer in my hall than this thing would. So yeah, it was expensive, but it does exactly what I need. And it's quite a nicely made little thing, so that'll be the sensor enclosure. So what we'll do now is we'll take apart the Sonoff and temperature sensor, take a look at the hardware inside, and then we'll go and build the thing. So the first thing we'll take a look inside of is the Sonoff itself, which has this little cover here you can remove. Just a single screw holds that on. There we go. And with this removed, you can see the mains terminals, which on this model are really nice sort of push fit, sort of almost like the maintenance free Wago type connectors that grip onto the wire with a spring, rather than having to faff about with screws. So this is a really nice touch. The other good thing on this is that unlike some of the Sonoffs, like the more basic ones, where like you feed the power in one side and it comes out the other, this has all the connections on one end, which is a lot neater for a sort of setup like this, where you can feed one or more wires in, or one or more cables in, and just have it all plugged into one side here, rather than having to have some going in the top, some going in the bottom, like on the more basic Sonoffs. So now let's go a little bit deeper. So once that's removed, you just need to spudger the casing open. It's dead easy to get inside. That's the only thing I would really say about this, is this thing does handle mains electricity. So I put it at a level that's like high enough that like kids can't reach it, because you could probably pull on this hard enough and break the cover off. It's not held on that securely. So I just put it like out of reach for people who might try and pull it off and touch live mains. But now let's take a look in more detail. So here we have the main board. It's a very nice layout where we have all little power supply circuitry here. There's the relay. There's two LEDs which shine through the top of the case. A button which is used for controlling it. With the standard firmware that switches it on and off. With your own firmware you can do whatever you want with this. This is also the button you need to hold down to put it into programming mode. There's the inputs all there. A little fuse behind there that isn't really removable, but that's fine. And down here we can see the programming headers. Out of the box there's no actual headers here, there's just some holes. But all you really need to do is buy a little pin header like that, solder it on, and then you have a nice handy little programming header there with pinouts available online. Finally, on the side here we just have that 2.5mm jack for connecting up the temperature sensor. So what we'll now do is take the board out to take a look at the bottom of it. So now here we have the board removed and we can see the bottom. Now I'm no big Clive, so I can't really go into full detail of this about like how the power supply all works. But from what I can see using my basic knowledge, this looks really good. They've reinforced solder tracks to the relay, so they've actually put solder on top to reinforce the current carrying capacity. And there's proper anti-tracking slots cut wherever there's like a sort of proximity between mains, like high voltage and low voltage. So they've properly cut out all these anti-tracking slots throughout it. So for example, that's where the transformer is, and they've cut out that slot underneath. So it does seem reasonably well thought out. In fact, I'd love to see Clive actually make a video of one of these because the hardware looks pretty good, so it'd be good to see how it is from an actual like electronics perspective. Next thing we can see up here is the ESP module itself. It's that little tiny chip there that does all the hard work. That's the Wi-Fi module and the little microcontroller in that one chip there. This chip over to the side here is in the flash memory, which can actually be upgraded. Out of the box it's got about 1 meg of flash, and that can be upgraded to higher capacity if you wanted to, although for my application that's absolutely fine. We can then see down here there's a little squiggly track here. That's the actual Wi-Fi antenna, which is just soldered to the PCB there. And then finally up here we can see where I've soldered that pin header on. The final thing I want to take a look at inside this is a 2.5mm jack that goes to the sensor. If you look at the pinout on this connection here is 3.3 volts, this pad here is ground, and this pad here is one of the GPIO pins which is designed to connect to the one-wire sensor. However, there's also this additional pad here which connects up to this empty space. So this actually isn't connected to anything. However, the other end of this pad here is actually connected to an extra GPIO pin, GPIO 4. This means that what you can do is put a 0 ohm link across this, or just a wire, across these pads here to short them together, and that will give you an extra GPIO pin on this connector that isn't there normally, which you can use to connect even more to the sensor. So what we'll do is we'll take a look at the sensor and see how we can do this. So I've now popped the sensor open and we can see something really interesting. So in here we have the actual temperature sensor itself, a crystal for the actual circuitry underneath we'll take a look at in a second, as well as this humidity sensor. However, if we look at the jack here, we can see something really good. So we have VCC, ground, and out, which is a one-wire signal. However, notice here that there's actually 4 wires going into this, and one that comes all the way through to the PCB here, where it just isn't actually connected to anything. That goes to that unpopulated GPIO pin on the board in the Sonoff itself. So this means that if we connect that up in the Sonoff to give that GPIO pin and expose it to take that GPIO pin and expose it to the connector, that GPIO will be available on this solder pad here. This means that when I take the sensor and mount it remotely from the Sonoff in that sensor box, I can hook an additional device up to this. So what I'll probably be doing is I'll probably hook up an LED inside that sensor box to indicate the status of the system, and I can actually drive that LED using this GPIO pin here. So that's a really nice touch that they've done that. I don't really know why. I suppose it's maybe just for flexibility of maybe not stopping using a one-wire sensor and using a SPI sensor or something that would require that extra wire. But it's really good that they've gone to the extent of that, gone to the effort of even bringing that wire all the way up into the sensor, which makes it really hackable. So yeah, we'll take a look at it once I've done it, but what I'll try and do is drive an LED using this GPIO pin to show the system status. So I've now removed the sensor from the case, and on the underside of the board we can see that we once again have those 3 connections with this pad completely unused, a few sort of passive components, and then this IC here which appears to do all of the reading from the sensors and then handles the one-wire connection to the Sonoff. The part number on that chip is 9202-702P3. However, I can't really find any information on it online at all, so that might not even be a part number, it might be a serial number or something, but yeah, that's the little chip that handles it all. But the key thing with this is having that extra GPIO pin there that I can use, so that when I mod this into that sensor box, I can actually hook up additional stuff such as an LED to it. So there you go, that was a look inside the Sonoff and temperature humidity sensor. And as you can see, it's really good. The hardware is really nicely designed with like what looks to be proper isolation and everything. And the sort of hackability of having that additional GPIO pin available at this temperature sensor end is really useful for connecting up additional devices to it. So what I'll now do is I'll go away and start building the thing and doing all my modifications, and I'll sort of pop back in every so often to show what I'm doing. Okay, so it's now literally months since I filmed that last clip, and I've finally finished all the hardware and software to get this thing going. So what we'll do first of all is we'll take a look at all the hardware and see the modifications I've done and how I've built this. I'll go and get it installed, and then we'll take a look at it running and take a look at the software I've built. So first of all, we'll take a look at the Sonoff itself. So the main thing I've done with this is build the custom firmware that runs on it, which I just built with the Arduino environment, so it's Arduino compatible firmware. And what it does is it makes the Sonoff connect an MQTT broker, which runs on a server, and that's how it communicates with the rest of the software. The software also has additional functionality for booting up, connecting to Wi-Fi. It's got a very basic serial console on it, so I can plug a serial adapter into that TTL header and use it to configure stuff such as Wi-Fi settings and MQTT broker settings. I've also built in some additional safeguards into this firmware. For example, if the Sonoff hasn't received a message from the server for a predetermined amount of time, it will turn the heating off. This means if the server were to crash or the network were to go down, the Sonoff won't stay sitting with the heating switched on, it'll turn the heating off. So I sort of put a few safeguards in for things like that. Apart from that, the only modification I've done to the Sonoff itself was to put that little jumper wire across those pads to bring the GPIO 4 pin up the sensor box. So I'll pop it open, take the PCB out, and we'll take a look at that modification. Okay, so here's the bottom of the board, and it's really tiny to see, but you can just see just about there. There's a little jumper link I've put across. So obviously on the factory installed stuff, they've used a surface mount 0 ohm link. However, obviously I don't really have any of that. I've not really got much for surface mount soldering or anything. So all I've done is just soldered a tiny little bit of wire across the two pins, and that's absolutely fine. And that's now linked GPIO 4 up to the connector that then goes off the sensor box. Now for the more interesting hardware stuff I've done, we'll take a look at the sensor box. So as you can see here, it's now got a wire coming out of it because I've mounted the sensor inside it. So if we pop this open, we'll see inside. So it's quite a nice little enclosure. I mean, obviously, it better be for 15 quid, but yep, screws shut, which is nice, and then you can just pop it open. So that'll be quite easy when it's mounted on the wall. And what we can now do is take a look at the hardware that I've put inside here. So this is the hardware I've put inside the sensor box. I've just removed the wire just to make it a bit neater to see. And what you can see is I've taken that original sensor and mounted it inside this with this screw. It actually fitted quite neatly. Then you can see there's a couple of additional components. So what I wanted was some sort of LED indicator in this to indicate the state of the heating, because this will be in the hallway so I'll be able to see it, whereas the Sonoff will be hidden away in a cupboard, so the LEDs on that aren't really any use. So what I did is I hooked up an LED to that additional GPIO pin. So you can see the LED there, it's a blue LED, and I've just basically hot glued it to the front of the case. And then within the heat shrink there's a resistor for limiting the current through it. I did a bit of digging trying to work out how much current a GPIO pin on an ESP8266 can draw, and it was quite vague, but stuff was saying round about 20 milliamps, and that's what this LED was rated for. It was 20 milliamp LED. So I was a bit concerned about drawing 20 milliamps from it because it was very much on the limit. So what I did just to be on the safe side is I've hooked up this transistor. So what happens is the GPIO pin actually triggers this transistor, and then the transistor switches the LED on and off. So we're not drawing the LED current from the GPIO pin, we're drawing that from the voltage rail here, and the transistor's handling the switching. So that was fairly simple, it's nothing too complicated, and they're both just hot glued in there and heat shrunk. It's not the neatest thing ever, but you won't see it when it's in use. So that's a look at the hardware I've built. So what we'll now do is going to take a look at where we're going to install it. So I'm now in my hallway with the heating program we're going to be replacing. So this is it here, it's a Honeywell CM707. And to be honest, it's actually one of the better programmers I've used for heating. It's pretty decent, but it's just, it's not smart, it's not internet connected, I can't control it remotely. Setting timers on it's a bit of a pain, so that's why I want to replace it. So what we'll need to do is take this programmer off the wall and then fit the Sonoff instead. So bizarrely it's battery operated, which doesn't really make much sense because there's a full mains supply to this, so I don't know why they put a battery operated one in, but whatever, that's obviously what I've done, but we take these two batteries out, just two AA's. Should be able to pull this off the wall. So just need to stick a screwdriver in there and it just sort of unclips like that. And then this whole unit will just pull off the wall. So that's the old programmer there. So now on the wall we can see we have this bracket with these two wires going into it. One of these is a switch live and one of these is a permanent live. So that's what connects how the thermostat controls the boiler. Now obviously because it's battery operated there isn't actually a neutral connected here, but it is actually wired with 3-core and earth cables. So there is an extra wire in there that could be used for the neutral. It's just for some reason they've decided to use a battery operated programmer. No idea why. So what we'll need to do is we'll need to take this bracket off and mount the Sonoff instead. So from a neatness perspective, I don't want the Sonoff sitting in the hall because it's quite ugly, but on the other side of this wall is a cupboard. So what I'm going to do is I'm going to mount the Sonoff in the cupboard and take this cable here and bring it out the other side of this wall and wire it into the Sonoff inside the cupboard. What I'll then do is mount that sensor box with the sensor in it over this hole and feed that cable with the 2.5mm jack through the wall, pop it out on the other side and plug it into the Sonoff. So it'll look a lot neater, so all you'll have here is that little sensor box in place of this programmer. Now I'm not going to film that on camera and try and talk through doing it because if I do that it'll take 10 times as long. But what I'll do is I'll go and install it all and come back and show the installation once it's complete. So there you go, that's the sensor box now installed in the hallway. Now let's go and take a look at the Sonoff. So I'm now in my hall cupboard, which you'll have seen before in the network install videos with all the networking stuff up there. And if you look behind the door here, you can see we have the Sonoff installed. So what we've got here is we've got the Sonoff mounted on the wall, and it's all wired in through this MK switch connection unit. This is a double pole switch, so I'm using this to switch the permanent live and neutral connection from the boiler. The switch live is then just connected using a Wago connector in the back of this to connect it through to the Sonoff, just because it's only a double pole switch. Having a switch here is really good. It means I can isolate the power to the Sonoff without having to turn the boiler off. That's quite useful because if the Sonoff say crashed and I need to restart it, or I wanted to connect up the serial header and flash new firmware or change the settings, I don't have to turn the boiler off because it gets a bit upset being restarted. It goes into self-test modes and stuff like that. So having just a dedicated switch just for the Sonoff is pretty useful. This then connects out onto this 4-core flex that connects into Sonoff. And we've also got this cable here which goes to the sensor box, which just feeds out through the switch connection unit. It doesn't actually wire in there at all, it just goes straight through the wall into the sensor box and neatly goes into the side of the Sonoff there. So it's a very neat installation. You can barely see it, it's completely hidden here, very neatly mounted to the wall. You'll see the Wi-Fi light on the Sonoff's lit up, and you'll see it'll blink every so often, and that blink just indicates that it's taking a temperature reading and sending it off to the server. So it does that every 10 seconds or so. But yeah, that's hardware install. Now let's take a look at the software side of things. I looked at pre-made solutions such as Home Assistant, however it didn't really do what I needed. What I wanted was a complete system where I could build my own user interface and design it exactly how I wanted it. Not use an existing interface and then write bits of YAML to make it do what I want interface with my hardware. I wanted to build it with my own complete custom interfaces. I initially wanted to just build a simple application just for really the heating. However, I got a bit carried away and ended up building this, which I've creatively named Smart Home Hub. I really need to come up with a better name. This is basically a Python application, and the idea is that it's designed to be very modular. So you create a module for each sort of device or each system you want to control, and you install it into the system. Much like how you install plugins on a WordPress website, for example. The whole thing's built in Python and then runs in Docker. So I've got my server, which runs FreeBSD. On that, I've got a Debian virtual machine running in Beehive. That runs Docker, and then all this stuff is deployed through Docker across several different containers. The main application itself is built in Python with a web interface provided by Flask, and then there's separate containers for Redis, which is used for background data storage, and MQTT, which is obviously the MQTT broker. So this is the main interface here, and initially it starts up to this dashboard screen. This allows different modules to display different widgets. Of course, I've only got a central heating module for now, so it only shows central heating here. However, if I had a module for lighting installed, there could be a widget, say, placed over here that would be used for the lighting. Down the left-hand side here, you can see all the modules that are installed, where I've got the central heating module and the InfluxDB logger we'll look at later. If you go into the central heating module, you see we get the very same widget appearing here, however there's now a bit more control. So from this you can do basic control of the system, so I can switch between manual control and timer control, and if it's on timer control, it'll start operating based on timers that I have set. If it's on manual control, I can switch heating on and off as I want to, and this is what I'll use mostly. So in the simplest form, we've got this button here, it says turn on now indefinitely, and I press go, and that'll turn the heating on until I switch it off. There's then a thermostat control down here, which lets me set the temperature the thermostat's set to. So because the current temperature is higher than the thermostat, the heating state is on, boiler not running. And if the temperature were to decrease or I were to increase the thermostat, the boiler would turn on. And we'll take a look at that later. Turn that off, it switches all off again. Under timers, we can go in here. I've not got any set up for now, but you can add timers, so you set a start time and an end time. The temperature you want it to be set to when that timer triggers, and you can pick which days that timer triggers on. So you can either tick them individually, or you can pick groups such as weekdays, weekends, or you can have the weekend and then pick Wednesday as well. And it all works fairly simply like that. You can build up a big list of timers here, and when the heating's put into timer mode, it'll operate based on these timers. There's then a settings page, which allows me to configure some settings. This gives me so much more control than an old-fashioned thermostat. For example, I've got this value here, which is how many temperature readings I average before classing that temperature as the actual temperature. So I take 6 readings. The readings are taken every 10 seconds. So the temperature that this heating works off of is a 1 minute average. I've also got these values here, which let me set how high or low the temperature has to be above or below the thermostat value before the heating switches off. This gives it a bit of a buffer, so I don't have incidents where the temperature is right on the border of the thermostat temperature, causing the boiler to switch on and off randomly. This lets me set a bit of a buffer zone, so the temperature has to vary a fair bit before the heating gets controlled. So that's the main dashboard module. The next one we have is the InfluxDB logger. So this allows data from MQTT topics to be logged to an InfluxDB database for dashboarding, which we'll take a look at next. If you go into here, we can see we have data for the server I connect to, which is just running in another Docker container on the Docker host. And if we go over to metrics, we can see we have some MQTT topics here that are being logged to InfluxDB. They're being logged to the dashboard database. The measurement's being called, whatever in this field here. And we can pick some types here to cast the data type to. So in this case, I want it to be casted to float because I'm graphing it as a floating point number. So this allows me to log data to InfluxDB for graphing purposes. So now let's take a look at those graphs. So I've now deployed Grafana, and I've sat that on top of InfluxDB to let me view the data that's been collected. So this is the dashboard I've built for now. Obviously there's a lot more stuff I can build with this, and I definitely want to do more. But this is a good basic example. So we've got logging the current temperature here, which is ridiculously hot because I stupidly turned the heating on to test, and now I'm absolutely dying. It's also logging the current humidity, and then it's graphing the data as well. So we can see the humidity is being graphed here, and when the heating was turned on, the humidity dropped quite significantly. Same for temperature. We can see we've got temperature, and you can see when I turned the heating on round about here, the temperature started increasing, and now I've turned the heating off, it's sort of flatlined. We can also go back over historical data. We can go as far as 24 hours back, or even further, and you can see the data that's logged. And it's actually really interesting to look at. For example, here you can see last night when I opened my bedroom window before I went to bed, you can see the temperature decreased quite significantly. And then you can see in the morning when I came out the shower, and the bathroom was very humid, the humidity jumped quite significantly when I opened the door. We can go back even further. We can go back over 2 days or even longer. InfluxDB and Grafana are really good for time series data, so you can go back hugely far into the past without it slowing down, which is great. I've also put the code up on GitHub, so if people are interested in seeing it, you can find it there. There's a link in the description. Now be warned, the software is completely not finished, not remotely polished, with absolutely no documentation and loads of stuff still needing done. However, it's all up here, so you can take a look at it. So we've got everything from the Sonoff firmware here, all the way to the main Home Automation Hub's application itself, and then the individual modules for central heating control and the InfluxDB logger. It all does work. The version up here is the version that I'm running in production effectively. However, there's no documentation, and it does need a bit of refactoring, so definitely worth taking a look at if you're interested, but it's not completely finished yet. I've deployed the software with a sort of split DNS configuration. So if I'm at home and I connect to it, it'll connect me in straight away without any authentication. If I'm away from home and I connect to it, on my phone for example, I'll connect to a reverse SSL termination proxy on my server, which will then require authentication to let me in, and it'll then, when I've authenticated, it will then let me through to access it. So I can still access it remotely despite it being hosted on my server at home. I also put a fair bit of focus into making it a fully responsive web interface, so it works really well on mobile. So what we'll now do is we'll see a live demo of it running on my phone and watch it controlling the heating. So now let's take a look at this running live. So as you can see here, we have the interface on my phone, which is a nice responsive web interface. And if we turn the heating on here, the LED on the sensor box will light up solid. This is indicating that the heating is switched on, but the temperature is currently too high in the room. It's higher than the thermostat value, so it's not going to actually fire the boiler yet. So now if I increase the thermostat temperature to higher than the room temperature, you'll see the boiler will switch on. The interface will show that the boiler is running, the light on the sensor box will start to blink, and the boiler will start to fire up. So as you can see, it's fully functioning. I've tested this a fair bit and it seems to work really well. It'll switch the boiler on, and when the room gets the right temperature, the boiler will switch off again. So yeah, the whole system actually works and controls my boiler perfectly. So there you go, that was a look at my homemade smart central heating control system. And overall I'm really happy with how it turned out. It's taken a huge amount of effort to get to this point. The hardware was fairly quick to build, but the software took ages, mainly because I overcomplicated it, but I spent a lot of time building the software side of things. However, it's now exactly what I wanted. It has all the functionality that I need, and it should be very expandable for use in the future as I get more smart devices. So yeah, thank you very much for watching, and stand by for more smart home videos where I probably try and get other sort of devices and build similar things to this, and we'll see what happens in the future. So yeah, thank you very much for watching.